Hello everyone. In this video, we are going to discuss the limit theorem. So here we will be illustrating and demonstrating the limit laws. So itong mga laws na ito ay makakatulong para mas mapadaling isolve or i-evaluate yung limit ng certain function. Okay, so let us have first the limit theorem number 1. So according to this theorem, the limit of a constant is the constant itself, or if k is any constant, then the limit of k as x approaches c is equal to k. Okay, so as long as you have a constant, the answer will always be the constant itself. Example, the limit of 2 as x approaches 0. Whatever the value of c here, if we have a constant, the answer will always be the constant. And since we have 2 here, and that is a constant, so the answer will be 2, right? Now, for letter B, we have limit of negative 5.12 as x approaches 100, so the answer will be negative 5.12. For letter C, so we have the limit of pi as x approaches 1. So the answer will be pi, since pi here is a constant. And that is approximately equal to 3.14, right? And for letter D, we have the limit of 1000 as x approaches c. So here, the value of c is not given. However, since we have a constant, which is 1000, so that will be our limit. Okay, so the answer will be 1000. Okay, so that is for limit theorem number 1. For the second theorem, it states that the limit of x as x approaches c is equal to c. So in notation, we have this one. So this theorem is also called the substitution theorem kasi parang nag-substitute tayo ng value ni c to your x. Okay, example, we have limit of x as x approaches 5. Since we have x here and x also here, so let's just substitute the value of 5 to your x. So the answer will be 5. Okay? For letter B, we have limit of x as x approaches 0.25. So our answer will be 0.25. Letter C, meron tayong limit of x as x approaches negative 100. So the answer will be negative 100. And for letter D, we have the limit of x as x approaches e, the Euler number, that is approximately equal to 2.718, right? So our answer will be E. Okay? So let's proceed to the third theorem. Okay, so for the remaining theorems, we will let the limit of f of x as x approaches c be equal to L, and the limit of g of x as x approaches c be equal to m. Okay, so for the third theorem, this is the constant multiple theorem. If k is any constant, then the limit of k times f of x as x approaches c is equal to k times the limit of f of x as x approaches c, or just equal to k times L, since the limit of f of x as x approaches c is equal to L. Okay? So that's it. Now, observe that parang finactor out lang natin yung value ni k sa expression na to. So from here, we have limit of k times f of x. Si k, pinalabas lang natin. So that's why we have k times the limit of f of x as x approaches c. For example, suppose we have the limit of f of x as x approaches c be equal to 5. So the limit is already given. So this is our L, which is 5. Then, for letter A, let's solve for the limit of 3 times f of x as x approaches c. According to the theorem, we can just factor out the numerical coefficient. So here we have our numerical coefficient equal to 3. So we can just factor out 3, and we have times the limit of f of x as x approaches c. And we know that the limit of f of x as x approaches c is equal to 5 from the given assumption. So we have 3 times 5. So our final answer will be 15. Okay, now let's try another one. The limit of negative 2 times f of x as x approaches c. So again, we can just factor out negative 2. So we have negative 2 limit of f of x as x approaches c. And again, the limit of f of x as x approaches c is equal to 5. So we have negative 2 times 5. And that is equal to negative 10. Okay, so that will be our answer. For the last one, we have limit of 4 over 5 times f of x as x approaches c. The same process. We will just factor out 4 over 5. So we have 4 over 5 times the limit of f of x as x approaches c. And that will be equal to 4 over 5 times 5. And that is equal to 4. And that will be our final answer. Okay, so let's proceed to limit theorem number 4. Okay, so according to the theorem, this is the addition or subtraction theorem or the sum or difference theorem. So we have the limit of the quantity f of x plus or minus g of x as x approaches c is equal to the limit of f of x as x approaches c plus minus the limit of g of x as x approaches c. And since the limit of f of x as x approaches c is L, so we have L here plus minus the limit of g of x as x approaches c is m, so we have plus minus m. Okay, so as you can see, parang dinistribute lang natin yung limit sa bawat function. So we have here limit of f of x and limit of g of x. So we have this one. So nahiwalay yung dalawa. So if we are using plus, so plus rin yung gagamitin natin. If minus, minus rin. Okay, so let's have this example. Suppose we have the limit of f of x as x approaches c equal to 2 and the limit of g of x as x approaches c equal to negative 3. Then, let's try this one. So according to the theorem, we can just distribute the limit. So we have here the limit of f of x. So ihiwalay lang natin yung f of x at g of x as x approaches c plus, since we have plus here, the limit of g of x as x approaches c. And from the given conditions, we have the limit of f of x as x approaches c is equal to 2 plus the limit of g of x as x approaches c is equal to negative 3. And this is equal to negative 1. Okay, and that will be our answer. For letter B, we have the limit of f of x minus g of x as x approaches c. The same process. We will just separate the two functions. So we will take the limit of both functions. We have as x approaches c minus the limit of g of x as x approaches c. And since we have the limit of f of x as x approaches c equal to 2, then we have minus, for g of x, we have negative 3. And this is equal to 5, since this will become plus. Negative of negative 3 will become plus 3. So 2 plus 3 is equal to 5. So that's it for the fourth theorem. For the fifth theorem, we have the multiplication theorem or the product theorem. So almost the same lang siya sa sum or difference. So parang na-distribute lang rin yung limit sa bawat function. So the limit of f of x times g of x as x approaches c is equal to the limit of f of x as x approaches c times the limit of g of x as x approaches c. And that will be equal to L times m from our given assumption. Okay, example, if we have the limit of f of x as x approaches c equal to 5 and the limit of g of x as x approaches c equal to negative 2, then the limit of f of x times g of x as x approaches c will be the limit of f of x as x approaches c. Apply the theorem. So we have times the limit of g of x as x approaches c. And since the limit of f of x is 5 and the limit of g of x is negative 2, then we have 5 times negative 2 equal to negative 10. And that will be our final answer. Okay, so ganun lang yung gagawin natin sa multiplication theorem. Now, for the next one, so we have the sixth theorem, the division or the quotient theorem. So the theorem states that the limit of f of x over g of x as x approaches c will be equal to the limit of f of x as x approaches c over the limit of g of x as x approaches c, or just equal to L over m, where m should not be equal to 0 in this case. Okay, so parang na-distribute lang ulit yung limit natin. So we will take the limit of the numerator over the limit of the denominator. Example, suppose the limit of f of x as x approaches c is 3, and the limit of g of x as x approaches c is negative 6. Then, let's solve the limit of the quotient of f of x and g of x. So according to the theorem, we will just take the limit of the numerator and the denominator. So limit of f of x as x approaches c over the limit of g of x as x approaches c. So from that, we will now have 3 over negative 6, right? And this is just equal to negative 2. Okay, so our limit will be negative 2. Okay, now let's try another one. How about if we have this one? For f of x, the limit is 0, and for g of x, we have 4. So let's try again to find the limit of the quotient of f of x and g of x. So applying the theorem, we have the limit of f of x as x approaches c over the limit of g of x as x approaches c. And this is equal to 0 over 4. And we know 0 over 4 is equal to 0. And that will be our limit. Okay? Okay, another one, the last example. Suppose we have limit of f of x as x approaches c equal to 2, and for g of x we have 0. Then we have, for this one, limit of f of x as x approaches c over limit of g of x as x approaches c. And this will be equal to, we have 2 over 0. And we know that this expression does not exist or undefined. Therefore, we conclude that the limit of f of x over g of x as x approaches c does not exist. Okay, so that's it for this one. So in this case, if the denominator is 0 and the numerator is not 0, then the limit does not exist. Okay, so that's it. Now, let's have the seventh theorem. So that is the power theorem. So according to the theorem, the limit of f of x to the power of n as x approaches c is equal to the limit of f of x as x approaches c to the power of n, or equal to L to the n. So ang ginawa lang natin dito, pinasok natin yung limit sa loob. Okay? So take note, our n here is an integer. Example, the limit of f of x as x approaches c is equal to 2. Then, let's try this one. So, according to the theorem, ipapasok lang natin yung limit, right? So, from here, pasok natin dito, magiging limit of f of x na siya as x approaches c to the power of 3, right? And since the limit is equal to 2, so we have 2 to the power of 3, and this is equal to 8. Okay? For letter B, we have the limit of f of x to the power of negative 4 as x approaches 3. The same process, ipapasok lang natin yung limit. So we have f of x as x approaches c to the power of negative 4. And we will have 2 to the power of negative 4. Since we have a negative exponent, to make it positive, we will just take the reciprocal of 2, and we have 1 over 2, then take the exponent. Magiging positive na siya. So we have 1 over 2 to the power of 4. And this is equal to 1 over 16. Okay, and that will be our final answer. Okay, now for the last theorem, this is the radical theorem. So this theorem is somewhat tricky. We need to consider some things before we conclude for the value of the limit. So the theorem states that the limit of the nth root of f of x as x approaches c is equal to the nth root of the limit of f of x as x approaches c. So ang ginawa lang, pinasok lang yung limit. Okay? So that will be equal to the nth root of L for any positive integer n. So this limit exists, okay, only if when n is even, your L should be greater than 0. So we have here provided that L is greater than 0 when n is even. So ano ba yung n natin? Yun yung index ng ating radical sign, right? So n is the index. So if your n is even, your L here should be greater than 0. Otherwise, the limit does not exist. Now, how about if n is odd? Then there's no problem when n is odd because we can evaluate right away. Whatever the answer after you evaluate, that will be your final answer when n is odd. But when n is even, again, your L here should be greater than 0. Okay, para mas maintindihan, let's try these examples. For the first example, we have the limit of f of x as x approaches c is equal to 16. Then, what is the limit of the square root of f of x as x approaches c? So, applying the theorem, so let us check first if ano yung n natin. So in this case, we have square root of f of x. So there is an imaginary 2 there, right? So may imaginary 2 dyan. So n here is even. So ang titingnan natin, dapat yung L natin or yung limit sa loob ng radical sign should be greater than 0. Okay, so applying the theorem, we have the limit of the square root of f of x as x approaches c, magiging square root of, ipapasok lang natin yung limit. So we have limit of f of x as x approaches c. And we know that is equal to 16. So we have square root of 16. And since 16 is greater than 0, so it satisfies this condition, then we can evaluate right away. And that is equal to 4. So our limit is 4. Okay? Now let's try this one. What if we have negative 16 as our limit? What will happen? So we have the limit of the square root of f of x. So sulat lang natin. As x approaches c, magiging square root of the limit of f of x siya as x approaches c. And we have the square root of negative 16. Here, negative 16 is not greater than 0. Therefore, in that case, and since our n is even, the limit will not exist. Therefore, we will conclude that the limit of square root of f of x as x approaches c does not exist. Okay? So that is now the case. Now, how about if we have this one? So we have the limit of f of x as x approaches c is equal to 0. Then what will be the limit of f of square root of f of x as x approaches c? So lagay lang natin dito, this will become the square root of the limit of f of x as x approaches c. Again, here, yung n natin ay even. Okay? So it should for the limit to exist, dapat yung nasa loob ay greater than 0. Okay? So we have here equal to the square root of limit of f of x is 0. So we have 0. Now, take note that 0 is not greater than 0. However, square root of 0, we know that square root of 0 is 0. And since here we are talking about the limit, and according to the theorem, if n is even, dapat yung L natin ay greater than 0. In this case, 0 is not greater than 0. Even though may value itong square root of 0, but since it violated the theorem, we can say now, or we can conclude that the limit of f of x as x approaches c does not exist. Okay? So we need to really consider the index of the radical sign. Okay? Especially if it is even. Dapat yung nasa loob ay greater than 0. Okay? The last one. So we have the limit of this is for odd na index. Okay? So suppose ang limit natin ay 8, then what is the limit of the cube root of f of x? So this will become the cube root of, ipapasok lang natin yung limit of f of x as x approaches c. And since we have the cube root of, the limit of f of x is 8, so we have cube root of 8. And since our n is odd, then there's no problem. We can evaluate right away. And cube root of 8 is just equal to 2. And that will be our final answer. Okay? So there. Another one. How about if negative 8 siya? So, the same pa rin yung gagawin natin. Paulit-ulit lang to. So, we have cube root of the limit of f of x as x approaches c. And since the limit is equal to negative 8, so we have cube root of negative 8. Even though less than 0 siya, walang problema kasi yung index natin ay odd, hindi even. So, cube root of negative 8 is just equal to negative 2, right? So, our final answer is negative 2. Okay? Now, last example for odd na index. How about if 0? So, what will happen here? Magiging, ulitin natin, we have cube root of the limit of f of x as x approaches c. So, magiging cube root of 0 siya. Okay, so again, yung n natin ay odd, so walang problema. And cube root of 0 is equal to 0. So, may answer siya in this case. And that is 0. Okay, so that ends the 8 theorems. Okay, so let's try to apply the following theorems in computing the limit of the given expression. So let's try letter A. So for letter A, we have the limit of 5 times f of x minus 2 times g of x plus h of x as x approaches c. So here, the limit of f of x is 2/3. For g of x, we have 8. And for h of x, we have negative 4. So let's just apply the given theorem. So here, since the three terms are separated by minus and plus sign, we can apply the sum or difference theorem. So according to the theorem, we can just um, distribute the limit, right? So what will happen here ay magiging ganito na siya. Limit of 5 times f of x as x approaches c minus, since minus itong nandito, limit of 2 times g of x as x approaches c, and we have plus here, limit of h of x as x approaches c. Now, we have 5 times f of x and 2 times g of x. These expressions are the same with the constant multiple theorem, right? So we can just factor out the numerical coefficient. So in this case, pwede natin ipalabas yung 5. So we have 5 times the limit of f of x as x approaches c minus 2 times the limit of g of x as x approaches c and plus the limit of h of x as x approaches c. Okay? And this will now be equal to 5 times limit of f of x is 2/3, so we have 2/3 minus 2 times g of x is 8. So we have 8 plus h of x is negative 4. So this will become 10 over 3 minus 16, and you have minus 4. And this is now equal to negative 50 over 3. And that is our final answer. Okay, so that's it for letter A. Now, let's try letter B. So, the same lang yung gagawin natin. We will apply the theorems. So, pwede nating i-distribute yung mga limit dito. Right? At chan. So, this one is quotient theorem, itong first. While this one ay para sa product naman. So, we will have the limit of g of x as x approaches c over the limit of the square of h of x as x approaches c times the limit of f of x as x approaches c. Now, sa baba, pwede nating ipasok yung limit according to the power theorem, right? So, this will become the limit of g of x as x approaches c over the square of the limit of h of x as x approaches c square times the limit of f of x as x approaches c. So, substituting the values, limit of g of x is 8 over h of x is negative 4, so we have negative 4 square, and times f of x is 2 thirds. And this will now be equal to 1 third. So that is our final answer. Okay, now for the last one, so just apply the radical theorem. So in this case, yung index natin ay even, right? So what will happen, magiging square root of, ipasok yun na lahat. So we have limit of 3 times g of x plus h of x plus 5 as x approaches c. Now we can distribute the limits here. So this will become the limit of 3 times g of x as x approaches c plus the limit of h of x as x approaches c and plus the limit of 5 as x approaches c. Again. Next, this will become, ito constant multiple tong first term, so we will factor out the numerical coefficient. So we have 3 limit of g of x as x approaches c plus the limit of h of x as x approaches c. Then we have plus limit of 5. Copy lang natin. Then after that, you substitute. So we have the square root of 3 times limit of g of x is 8. Then plus h of x is negative 4. And the limit of 5 as x approaches c, this is the limit of a constant. So the answer is the constant itself. So we have plus 5. And this will now be equal to square root of 25. Now, 25 is greater than 0. So, therefore, we can evaluate right away. And this is equal to 5. And that will be our final answer. Okay? So, that's it for this lesson. Thank you for watching.